Hello, welcome to Anybody Can Learn. Today we will learn error in linear regression in more detail. Recall that the linear regression model predicts the output using a specific equation, and the formula for multiple features is y hat is equal to x multiplied by w, or if we have only one feature, then we will use formula y hat is equal to wx, where y hat is the predicted output, x is the input feature, and w is the weight or parameter learned by the model. What is the error? The model always makes a prediction. Sometimes the prediction is exactly correct and sometimes it is not. The difference between the actual value and the predicted value is called the error. The error is represented by the symbol E or epsilon. This symbol is called as a epsilon, and the error formula is E is equal to y minus y hat, or E is equal to y minus x multiplied by w, where y is the actual output and y hat is the predicted output. Just now we see that predicted output is y hat is equal to xw. So this xw means predicted output. Let's see the example. If there are 3 students and the actual mark for the student 1 is 90, but the model predicted it as 88, then error is 90 minus 88, that is 2. For student 2, the actual marks are 80, but the model predicts it as 83. So error is 80 minus 83, that is minus 3. For student 3, the actual marks are 70, but the model predicts the marks 69. So error is 70 minus 69, that is error equal to 1. So these 2 minus 3 ones are the errors. In reality, the output is not exactly Wx. There is always some error involved. So the actual model formula is y is equal to Wx plus E, where y is actual output, Wx is predicted output, and E is the random error. The error is assumed to follow the Gaussian distribution. Gaussian distribution is also called as normal distribution, and it is a bell-shaped curve. Most of the errors are close to this 0. The large positive or the large negative errors are rare. So this is a Gaussian distribution curve, and most of the errors are in these clusters. The error is assumed to follow the normal distribution or Gaussian distribution. E follows normal distribution with mean 0 and variance sigma square. N means normal or Gaussian distribution, and this 0 mean of the error, and sigma square is the variance of the error. This E means error. Why does the 0 mean? The mean or average of the error is 0. This means positive and the negative errors cancel each other. The model does not consistently overestimate or underestimate. For example, if the errors are 2, -2, 1, -1 and 0, then its mean is 2 plus -2 plus 1 plus -1 plus 0 divided by 5. So 0 divided by 5 is 0, therefore mean is 0. What is the variance? Variance measures how spread out the errors are. If the error values are E1, E2 up to En, then variance is calculated by the formula sigma square is equal to 1 over n times the sum of the square difference between the each error and the mean error. This E bar is the mean of the error and n is the total number of errors. Let's see the example for variance. Suppose the errors are 1, -1, 2 and -2. Then its mean is 1 plus -1 plus 2 plus -2 divided by 4. So it is 0 divided by 4, therefore mean is 0. Now find out the error minus mean. So 1 minus 0 is 1, -1 minus 0 is -1, 2 minus 0 is 2, -2 minus 0 is -2. Now square the error minus mean. So 1 square is 1, -1 square is 1, 2 square is 4, -2 square is 4. Now add all these square. So 1 plus 1 plus 4 plus 4 is 10. So 10 divided by total number of errors. Total number of errors are 4. Therefore 10 divided by 4 is 2.5. So variance is 2.5. Constant variance means the spread of the errors remains the same for all input values. The variability stays roughly the same for all the input values. Suppose in our house size example, for the small input, that is small square foot of the size, the typical error ranges between plus or minus 5. Even the medium size house size, the typical error measures between plus and minus 5, and for large house size the error measures between plus or minus 5. So this is called as a constant variance, because even for all the input values the error remains the same. The error becomes larger and larger as the house size increases. The variance is not constant. For example, for our house size example, for smaller house size the typical error is between plus or minus 2, and for medium size house size it is plus or minus 10, and for large house size it is plus or minus 15. That means for different input we have the different error, therefore variance is not a constant. So this violate the standard of linear regression assumption. We know that the linear regression makes the assumption of E follows the normal distribution with mean equal to 0 and variance is sigma square. This is only one variance. There is only one variance, sigma square. It does not change for different observation. Therefore, model strictly assumes the constant variance. Let's summarize today's lecture. So error is the difference between the actual and the predicted values, that is E is equal to y minus y hat, and error follows the Gaussian distribution or the normal distribution. A Gaussian distribution is a bell-shaped probability distribution with most of the values are close to the mean, that is, most of the error lies close to the mean. Mean is the average of all errors, and variance is measures how much the errors are spread around the mean. The variance of error is the same for all observation in means it is a constant variance. If the variance of error changes, then it violates our assumption. So formulas for linear regression is y hat is equal to x multiplied by w. Error formula is E is equal to y minus y hat, where y is the actual output and y hat is the predicted output, and E is the error, that is prediction error. So the complete equation is y is equal to xw plus E, where y is the actual output and xw is the predicted output, plus it is a prediction error. Error distribution means error follows the normal distribution or the Gaussian distribution with the mean is equal to 0 and variance is sigma square, and variance formula is sigma square is equal to 1 upon n summation of square of ei minus e bar, where I ranges from 1 to n, where e bar is the mean of the error. Thank you.